Welcome to aminacademy.com. In strength of materials, let us discuss about expression for crippling load, both ends hinged. The load at which the column just buckles is called a buckling load, critical load, or crippling load, and the column is said to have developed an elastic instability. A little consideration will show that for a long column, the value of buckling load will be less than the crushing load. Let us do some expression for the crippling load for column at both end hinged. Look at this figure. It's a column length L having both ends hinged. The load at which the column just buckles or bends is called a crippling load. Consider a column AB of a length L. Length of column AB equal to L. Y equal to deflection. Here Y equal to deflection at the section X at the section X here. Now the moment due to crippling load, the moment due to crippling load. That means when load is applied, that column cripple, and the moment of this load is minus Py. Let it be the equation 1, and the moment equal Pi d square y by dx square. Equating these two expressions, 1 equal to, we have Pi d square y by dx square equal minus Py, or collecting one side, that is Ei d square y by dx square plus Py equals 0 is second degree differential equation for crippling load. Now here dividing throughout by Ei, we have d squared y by dx square plus P over Ei y equal 0. Therefore, the solution of the above equation we have y equal C1 cos x root of P over EI plus C2 sine X over X into P over EI. Then look at here. Therefore, where C1, C2 are moments constant of integration. C1 and C2 are constants of integration. This is the solution of this equation. Now, conditional at point A. Look at here, the crippling load at point A. A is at A x equals 0. What is y? At A x equals 0 and put x equals 0 in this equation, we will get y equal to 0 because here we have x and here also x. We have next at x equals 0, simply you can say at point x equals 0 there is no deflection at point x. Next, substituting these values in equation 1. Therefore, the equation 1 gives y equals 0, C1 cos 0 plus C2 sin 0. We know that cos 0 is 1, therefore 0 equals C1 into 1 plus C2 into 0. Therefore, C1 equal to 0. Then at second stage, look here at x equal to L. At x equal to L means this complete length at x equal to L and y equal to 0. Therefore, substituting the values y equals 0, C1 cos that x equal to L root of P over EI. P over EI plus C2 of sine L root of P over EI. Then we write 0 equal, here at C1 is already we have 0, put that one value, that is C1 equal to 0 plus C2 sine L into root of P over AI. Therefore, this let it be equation 3. Now, from the equation 3, therefore, we can say this is the conditions, that is C2 sine of L into root of P over EI equal 0. As C1 equals 0, C2 is also Therefore, at C1 is 0 and C2 also it become 0 because look at this expression. Therefore, we can say sine 0 is 0 or sine, it is sine 0 we can say 0. Therefore, C2 sine of L P over EI. Instead of 0 we can write it is equal to sine 0 and further or pi or 2 pi like. Therefore, taking least practical values, therefore L, because both sides sine, we can say sine 0 or sine pi like. Least value you can say L of P over EI is equal to pi, you can use it. First 0 is one value, another is first least value is pi. Therefore, from this we can get it the value of p, squaring both sides, L squared p over EI square root will go pi square. Then further P equal the load, crippling load is y squared EI over L squared. It's a crippling load. Crippling load for both end hinged. So far we discussed about what is crippling load and find expression for crippling load for the column at both end hinged. We have done. Please subscribe our YouTube channel.